For today's lesson, our focus standard comes from Grade 7, Geometry, Standard 6. Calculate the volume of 2- and 3-dimensional objects. Our topic comes from Analyzing Geometry Relationships, Volume of 3D Figures. Our essential question is, how do we use our understanding of area to calculate the volume of 3D figures? Please take a moment, pausing the video if you need to copy down the topic and the essential question in your header along with today's date, select the question column in your note column, and resume the video when you're ready to begin. In calculating the volume of 3D figures, we can essentially keep one formula in mind. Volume equals base times height. Now notice I'm using a capital B here. That's because it stands for something a little bit more than just base. Let's take a closer look. That capital B stands for the area of the base. So the first step is to find the area of the base, or the area, another way to think about that is the area of the face that gives the shape its name. And as we go through our 3 examples today, I will be talking more about what that means. So this is finding the area of the base, and then you multiply that value by the height of the figure, right? It's the area of the base times the height. The height gives it that third dimension. So let's take a look at our first example today. Here's a shape you're all well familiar with, I know, a rectangular prism. And I wanted to start with this example, talking about how this formula, volume equals base times height, would apply to a rectangular prism. This is the formula you're probably more familiar with for calculating the volume of a rectangular prism. Length times width times height. Well, remember this B stands for finding the area of the base, the one that gives it its name. We know that this is a rectangle, and so this would be its 2-dimensional shape, and then it has height, which gives it a third dimension. Well, to find the area of this rectangle, we multiply length times width. So this calculation right here, in this formula, when we multiply length times width, gives us the capital B, the area of the base. So go ahead, knowing these 3 dimensions, that this rectangular prism has a length of 12.5 millimeters, a width of 6 millimeters, and a height of 4 millimeters. So go ahead and calculate the volume of this rectangular prism. And then let's check back to compare. How'd you do? Multiplying the length times the width, 12.5 times 6, gave us an area of that base of 75 millimeters squared. Then we multiply that by 4 and get a volume that is equal to 300 millimeters cubed. Remember, when we're calculating volume, we're calculating how many cubes fit in this 3-dimensional space. So we use the cube to talk about the fact that this is a 3D measurement. Let's go ahead and take a look at our next example. For our next example, we're looking at a triangular prism. And once again, we want to look at how does this formula, volume equals base times height, where the capital B stands for the area of the base. Well, this triangular prism is called a triangular prism because of the triangular faces that give it its name. We first, to find the capital B, need to find the area of this triangular face. And then we'll multiply that by the height. So here's how we would do that. We know that the area formula for a triangle is base times height, notice the lowercase b, times the height of the triangle divided by 2. That's the area of the triangular base. So this bottom edge of that triangle is our lowercase base, 7 feet, times the height of the triangle divided by 2 will tell us the area of this base. Once we know that, we'll multiply it by the height of the prism. So the height of the prism is 3 feet. Go ahead, pause the video here to do your calculations, and then let's check in to see if we agree. How'd you do? First, I plugged in those values that we had talked about. So the base of the triangle was 7 feet times the height of the triangle, which is 5 feet, gave me 35. 35 divided by 2, which is the second part, finding the area of the triangle, was 17.5. So 17.5 represents the area of this triangular face that gives this 3D figure its name, the triangular prism. So now that we know that this area is 17.5, we multiply that by the height of the prism, which is 3. Doing so, we find that the volume is 52.5 feet cubed. Again, we're finding how many square cubes would fill this prism. And our answer was 52.5. Let's go ahead and take a look at our third and final example. For our third example, we're going to calculate the volume of this cylinder. So we're going to rely on the work that we did just a few weeks ago to be able to find the area of a circle, to be able to help us find the volume of this cylinder. So you guessed it. Let's fill in what we need, what information we need, or the formula we would use to find the area of this circular base. That's right. The area of a circle is found by taking pi times the radius squared. That'll tell us the area of this circle, so that we can then multiply it by the height of the cylinder to find the total volume. Go ahead and pause the video here to do your calculation and check back to see how our answers compare. How'd you do? Well, one of the first things you had to notice, since we're using the area formula for our circle to find the area of the space, is that the radius is half of the diameter. And in our image, we were given the measurement of the diameter. So the radius would be half of 5, and I've outlined that here. That would be 2.5. So check, did you fill that in properly in your calculation? So 2.5 squared equals 6 and 25 hundredths. 6 and 25 hundredths times 3.14, which is the value we've been using for pi, would give us an area for this circle of the base to be 19 and 625 thousandths. Some of you may have rounded that answer to 19.6 or 19.63. I decided to keep my answer here in its complete form. This value, the area of our circle, 19 and 625 thousandths times 8, gives us an exact value of the volume of the cylinder, which is 157 yards cubed. Did you remember to cube your units? Alright, so that is going to conclude our video today on how to find the volume of any 3D figure by using this formula, calculating the volume by the area of the base times the height. Please make sure your notes are complete and come ready to do more problems like this in class.